everyone. In this video, I'm going to talk about why it's a good idea to register your research design prior to engaging in any data collection. Okay? Um, so to start, one of the key requirements for scientific progress is that research results have to be reproducible. The underlying reason is that any lack of replication ultimately inhibits the elimination of false discoveries, which we obviously want to avoid, right? So what are the threats to reproducible science? Um, in this graph, we kind of have a schematic view of the deductive scientific method, where we can think of this as as an ongoing process where we generate and specify hypotheses. We design a study, we collect data, then we analyze these data to test our hypothesis, we interpret the results, and we publish and conduct a new we publish the results and then potentially conduct a new experiment. And then ultimately the process continues based on the previous results. We generate new or more specific hypotheses, design new studies, and so on, right? So that's the scientific kind of method and progress in a nutshell, right? And so obviously this can fail in many instances and can ultimately increase the likelihood of false discoveries, right? We have a couple of problems in each of these steps. Failure to control for bias when we generate specific hypotheses, running studies that have too low statistical power, poor data control. But then we have additional issues, especially when it comes to analyzing data and testing hypotheses. In the context, or in that context, we often talk about the issue of p-hacking. We also talked about publication bias in the sense that certain results are more likely to be published than, for example, null results. And this is one of the focus. One of the papers of the assigned readings for this week is focusing on that particular issue. And then we have harking. Harking describes hypothesizing after results are known, which essentially kind of describes this shortcut between interpreting the results given the data and then generating hypotheses that match the results after having looked at the data, right? So all these points, all these potential issues ultimately threaten reproducible research, and pre-registration is a way of addressing not all of those problems, but some of those problems, and those problems need to be addressed, okay? So what is the problem? The problem is that the combination of a strong bias towards statistically significant findings when it comes to publication, as well as flexibility in data analysis, can ultimately lead to irreproducible research, right? And ultimately that means false discoveries that actually do not represent the truth, right? So let's focus on the first aspect here. Strong bias towards statistically significant findings, right? And this is, as I mentioned, kind of one of the topics that was also kind of covered in the Gerber and Malhotra paper, where they showed that more published results in political science journals basically show results that are slightly below the threshold of statistical significance than there are publications or results that are slightly above the threshold of statistical significance, which should suggest that there is a bias to publishing or reporting only statistically significant results, okay? This is an example from a different study. This was in +1, where we see kind of the proportion of kind of significant results across different disciplines, and we see particularly here psychology with almost 90% of significant result in the published journals, which was of course in 2010. So these numbers might look a little bit different now. But essentially that describes this problem that when it comes to publication, there's a strong bias towards statistically significant findings. If you ever submitted an article to a journal, you'll have a much harder time to get that article published if you only show null results. And of course, that leads to problematic incentives. Okay. The way these incentives can play out lay in the fact that we have a lot of flexibility in terms of how we can analyze our data. Okay, and this is one way to think about this is the so-called garden of forking paths, where you can think of basically any kind of research project or any statistical investigation as you have a starting point where you want to test some hypothesis of does some independent variable x affect an outcome variable of interest y, right? And of course, it's usually not so simple that you can just, you ask that question and you have an answer, or you collect some data and you directly have an answer, because there are a lot of so-called researcher degrees of freedom in terms of how you want to actually answer this question, how you actually want to test this hypothesis, right? There are questions of how you measure the outcome, how you measure the independent variables, how do you deal with outliers, for example, how do you dichotomous variables to the extent that you want to dichotomize them, what types of models do you run, what types of control variables do you include, and so on, right? So there is a sequence of decisions that you have to make from the start of your hypothesis to the actual result, right? And as it turns out, these all of these potential decisions on this kind of a garden of forking paths leads you to potentially different results. And if some of them are significant and some of them are not significant, and researchers ultimately condition which results to, given the incentives that we talked about when it comes to publication, if researchers then choose model specifications and measurement strategies and so on, conditional on achieving the scientific result, achieving statistically significant parameters and so on, then ultimately that threatens the value and the actual interpretability of the p-value and f of statistical significance. Okay, this is a great article that kind of summarizes this argument of the garden of forking paths as researchers' degrees of freedom in making decisions as to how to analyze data, how to look at different subsets, and so on. And the big problem is, given this publication bias and the incentives that creates and the flexibility in how to analyze these data, we can actually ultimately create or find results that are significant, and we have to be careful not to condition on that result, because otherwise we ultimately jeopardize the conclusions that we can draw based on our analysis. Okay. And the consequences of that, as is mentioned here, is that the research ultimately is not reproducible, and that's ultimately what we want to avoid, right? And so one investigation of the reproducibility of research was this reproducibility project focused on psychology. It was a science publication in 2015, estimating the reproducibility of psychological science, and this is one of the graphs from that paper, where they examined a couple of classic original psychology studies, where 97% of those original studies found significant effects, and then they replicated them across multiple sites and across multiple iterations, and they found that after engaging in that replication exercise, they found that only 37% of the replications were actually statistically significant, right? So that shows you that ultimately these problematic incentives when it comes to publication, as well as the flexibility in how to analyze the data, ultimately lead to research results that we can't actually trust. ultimately we have a lot more false positives, a lot more a lot more results that are actually not replicable in our journals than we would like to have in order to have sound scientific progress. Okay, so how can pre-registration help in this context, or more broadly, what is pre-registration actually? In short, pre-registration is a time-stamped, read-only version of your research plan created before you begin data collection, right? There are a couple of components that have to be part of that, um, the the Humphreys paper focuses on some of those components of that pre-registration, or they kind of discuss it in the context of a mock report. But in general, the important key components of a pre-registration are, of course, the hypotheses that you want to test. But you also have to outline the data collection procedures, as well as manipulated and measured variables. So how exactly do you conceptualize your theoretical constructs? How do you measure your independent and your dependent variables? What are the types of treatments, the interventions that are part of your study, and so on. You also have to specify your statistical model, as well as the inference criteria. To what extent do you use like a 5% cutoff for statistical significance, and so on, right? So those are the key components of a pre-registration, and together this pre-registration as a time-stamped read-only version of your research plan that you publish before you actually collect your data, that is ultimately an answer to a lot of these problems that I outlined previously when it comes to the lack of replicability in scientific research. Okay. Um, Another important thing to note here is that one way to do this is to register your design, collect your data, write your paper, and then ultimately submit this to a journal, including the pre-registration. But there's also the possibility, and some journals in political science now allow for this possibility as well, is to submit what is called a pre-registered report. And the underlying idea is that the research plan ultimately undergoes peer review before the data is collected, before the results are known, and so you submit basically the pre-registration to a journal. Then the journal or the reviewers ultimately accept or reject that pre-registered report, and then your study is ultimately conditionally accepted prior to collecting the data, prior to knowing the results, and will very likely be published as long as after your data collection you ultimately, of course, follow the steps that were outlined in your pre-registered report, right? So when the research plan undergoes peer review before the results are known, for example, by a journal, then the pre-registration becomes part of what is called a registered report. Okay. So next, what problems really? I mentioned a bunch of problems in the beginning. What problems does pre-registration actually fix? The first problem is related to publication bias, and that's what we call the file drawer effect, which means that selective publication ultimately occurs, oftentimes based on statistical significance, right? It's a tendency to publish positive results but not publish negative or non-confirmatory results because for the journal they seem less interesting, for example, right? And the underlying problem is that then negative results or failures to reject null hypothesis ultimately never see the light of day, which ultimately means that a lot of published results are essentially overestimates of true population effects. Okay, so how can pre-registrations help mitigate this problem? Well, if you have a record of studies prior to collecting the data and prior to publication, you have a record of research that has been done, even if that research ultimately does not get published. So having data on pre-registered studies allows you to examine to what extent there's also a publication bias when it comes to when it comes to actual journal publications. Okay, so that's the first problem. The second problem that I mentioned in the beginning of the video is p-hacking. And what we mean by p-hacking is ultimately mining your data in order to see patterns in this data that are statistically significant without first specifying a hypothesis, right? So that goes a little bit beyond the Garden of Forking Paths argument, where you basically just look through the data, you find a significant result, and then you kind of write a paper around that, right? And of course, that is mitigated by the fact if you pre-register your hypothesis, pre-register your design and your analysis, you cannot engage in p-hacking without deviating from your pre-registration, okay? And lastly, harking this idea of hypothesizing after results are known, which is of course kind of related to p-hacking, but it's not exactly equivalent, right? With p-hacking, you're just looking for significant results. With harking, you're examining patterns in the data. For example, you could think about like subset analysis where you include a moderator or some interaction effect and so on, and then kind of build the hypotheses and build your theory around the results that you already have seen, right? So harking means hypothesizing after results are known. You create a hypothesis based on or informed by your study's results, okay? And of course, that is also not possible if you pre-register your hypotheses, okay? So ultimately, pre-registration, I should move myself out of the way here a little bit. So ultimately, pre-registration makes the distinction between kind of confirmatory hypothesis testing research and exploratory or hypothesis generating research, and makes this distinction explicit and makes it more clear. And this is not to say that research is only confirmatory. Of course, we need exploratory analysis, but the key problem is that these need to be distinct, and it needs to be clearly communicated whether your results and your analysis are ultimately hypothesis test and confirmatory, or whether they're exploratory and hypothesis generating, okay? Both are clearly important and an integral part of the kind of research endeavor, but we need to be sure whether results can be interpreted as confirmatory or exploratory, okay? Okay. So just to kind of talk a little bit more about the distinction between confirmatory and exploratory analysis. On the one hand, when we think about the context of kind of confirmation in the research process, when we think about hypothesis testing, or that's ultimately what we talk about when we think of traditional hypothesis testing, right? We have some theory, we have a hypothesis, we collect data to test that hypothesis, and ultimately we want to hold those results to the kind of highest standards of rigor. We want to minimize the likelihood of false positives, and in this context, we rely on p-values in order to evaluate statistical significance, in order to basically as a sign to evaluate or to reject a given null hypothesis in comparison to some alternative hypothesis based on our theory. Okay, so classic or traditional hypothesis testing is kind of clearly belongs to this context of confirmation or rejecting null hypothesis in favor of alternative hypothesis. Okay. When we think about exploratory analysis, we're in the context of discovering new patterns or probably or potentially developing new hypotheses, right? So here we're talking about pushing knowledge into new areas. We're looking at data. We're trying to discover new patterns, generate new hypotheses, potentially finding unexpected relationships And here the idea is not to minimize false positives, but rather the goal is to minimize false negatives, right? We want to be able to discover new, potentially interesting relationships, new patterns, new structures, and so on. And here the key point is that p-values are essentially meaningless. P-values give us the probability of observing our data under the assumption that the null hypothesis was true. That's what the p-value tells us ultimately, over repeated sampling. And when we're kind of in the context of exploratory analysis, in the context of kind of discovering new patterns, we're not trying to reject some null hypothesis in the context of some alternative theory, but we're just trying to find new patterns, right? And so in that sense, p-values are essentially useless, because the goal is not to reject a null hypothesis, right? So the key problem here that pre-registration ultimately allows us to address is that oftentimes researchers are engaging in essentially exploratory analysis, essentially engaging in discovery, trying to find new patterns, but ultimately selling those as confirmatory, right? And the problem is that presenting exploratory results as confirmatory ultimately might increase publishability and might increase the, how interesting your results seem to a journal, but they achieve this increase in publishability at the expense of the credibility of the results, right? So ultimately, we're increasing our chance of false positives, and we're ultimately creating research that in of itself is not reproducible. So in order to prevent that, we need to include pre-registration as a key tool to address this problem and to separate the confirmatory part of hypothesis testing and the exploratory part of kind of discovering new patterns in data. Okay. So, kind of to summarize, what does the ideal research workflow look like? Of course, we start with a theory-driven, ideally we start with theory-driven a priori expectations. We then write a pre-registration. We register the design, the hypotheses, the specific statistical tests, the measurements, and so on. And then we actually collect data. Then we're basically in this confirmation phase. We're testing our hypothesis that we specified before based on the models that we specified before, and then ideally write a paper and publish that paper that presents the results, regardless of the underlying significance, the statistical significance of our findings. Ultimately, the decision to publish or the decision to submit this should be independent of the outcome regarding statistical significance, right? The important piece here is also to emphasize, and this is also emphasized in the Humphreys paper that we're going to talk more about in the Q&A session, is that writing these pre-registrations does not mean that you're kind of not allowed to engage in discovery, to engage in exploratory research. The key point here is that it's a communication device to clearly separate both parts, right? So to clearly identify the parts that were confirmatory hypothesis tests, and to separate the exploratory parts where we try to find new patterns in data, right? So the idea is not to constrain researchers and prevent them from doing that. They can of course engage in exploratory analysis. The key point is just to make explicit which part of an analysis is exploratory and which part of an analysis is confirmatory. Okay. So again, the key point here is that a pre-registration separates hypothesis testing from hypothesis generating research. You can still, after you collected the data, find new patterns to generate new hypotheses, but ideally what you're going to do is then use that to write a new pre-registration, to collect new data, to ultimately then test your new hypothesis that you based on the data that you have already seen. Okay, so both pieces are important, and pre-registration don't prevent you from engaging in discovery and exploratory analysis, but they are a communication device that clearly separates both as different parts of the research process. Okay. So to provide a very brief summary, why should you pre-register? First, it makes your science better by increasing the credibility of your results as a communication device. It allows you to stake your claim to your ideas earlier. And thirdly, it is an easy way to plan for better research, right? So not only kind of does it lock in your hypothesis and makes your results more credible, it also forces you to think more deeply about your design, about how to measure your outcomes of interest or your independent variables. And that thinking deeply about a lot of these kind of detailed questions before you actually start collecting the data means that you can still make adjustments if you all of a sudden realize, okay, maybe a certain measurement approach is more advantageous, or maybe I forgot to include a certain, potentially crucial moderating variable, and so on, right? So the more you think, the deeper you think about your project prior to collecting your data, the better it will be for your project. So that alone is a huge advantage of pre-registration. Next, when can you pre-register? So there are actually different stages. Of course, the ideal scenario is that you pre-register your design right before your next round of data collection, right before engaging in data collection. You can also, in your if you're already, you already submitted a paper to a journal and you asked to by reviewers asked to collect more data or to run additional analysis, run additional experiments, that's also a great position where you can pre-register your additional hypothesis or your additional data collection as part of that peer review process. And you can also pre-register your hypothesis before you begin analysis on an existing data set, right? Even if you work with existing data, that doesn't mean you can't pre-register your analysis. Of course, you have to kind of clearly communicate that this is not prior to data collection, but prior to actually analyzing the data. But it nevertheless is helpful to pre-register those types of analysis. Okay. Lastly, some three quick tips for writing up pre-registered work. First, whenever you have a pre-registration, you have to include a link to your pre-registration as part of your manuscript. I just included one link to an LSF pre-registration on here that you can check out as well. You should always report the results of all pre-registered analysis. So as soon as an analysis is part of your pre-registration, you have to include that analysis in your manuscript. Otherwise, that invalidates ultimately the idea behind pre-registering your hypotheses. And then thirdly, any unregistered analysis, it's fine to run additional analysis. It's absolutely fine to look at additional subgroup comparisons or try a different specification of your model and so on. But the key point here is that this must be clearly communicated. Any unregistered analysis must be transparent. It must be obvious and clear to the reader which part was pre-registered and which part ultimately was part of this more exploratory analysis. All right. So I hope this summary was interesting, and I hope it convinced you to think about pre-registration prior to engaging in your own data collection for your dissertation and beyond. And I'm looking forward to our Q&A session where we're going to talk more about the two papers that are related to pre-registration and publication biases in political science. as well as about, of course, difference in difference designs. All right, I'll talk to you soon.